Welcome to qnawire.
Okay, so problem number 41 states that for the sodium atom of example 40.8, find A, the ground state energy, B, the wavelength of a photon emitted when n equals 4 to n equals 3 transition occurs, and C, the energy difference for any delta n is equal to 1 transition. So for example 40.8 in the book, we're given two things. We're given the mass of a sodium atom, which mass of Na is equal to 3.82 times 10 to the minus 26 kilograms, and we're given that the force constant, K prime, is equal to 12.2 newtons per meter. So the whole example 40.8 is about how you can model the atomic vibrations of a crystal as a harmonic oscillator. So where the energy levels of a harmonic oscillator are given by n plus 1/2 h bar omega, where omega is equal to the square root of k prime over m. So now for part A, in order to solve for the ground state energy, E sub 0 is just equal to 1/2 h bar omega, which is equal to 1/2 h bar times the square root of k prime over m, which is equal to 1/2 times 1.055 times 10 to the minus 34 joule seconds times the square root of 12.2 newtons per meter divided by 3.82 times 10 to the minus 26 kilograms. Okay, so we work this out and we get E sub 0 is equal to, after the plug and chug, we get E sub 0 is equal to 9.43 times 10 to the minus 22 joules. Or in electron volts, it's given as E0 is equal to 9.43 times 10 to the minus 22 joules times 1 electron volt divided by 1.6 times 10 to the minus 19 joules, because there's 1.6 times 10 to the minus 19 joules per electron volt. So this gives you 5.89 times 10 to the minus 3 electron volts. Okay, so for part B, it asks what's the wavelength of a photon emitted when the n equals 4 to n equals 3 transition occurs. So we need to figure out what that change in energy is between those two. So delta E is equal to E sub n plus 1 minus E sub n, which is in this case E sub 4 minus E sub 3, which is going to be equal to 4 plus 1/2 h bar omega minus 3 plus 1/2 h bar omega, which is equal to h bar omega times 4 plus 1/2 minus 3 minus 1/2. So these cancel and you end up with delta E. Delta E is equal to h bar omega, which is just equal to 2E0. So we can use this relationship to figure out really easily that the energy of the photon, so delta E, or the energy of this transition, I should say, delta E is just equal to 2 times 5.89 9 times 10 to the minus 3 eV, which is equal to 0.0118 electron volts. All right, so now what we need to do is we need to find the energy of the photon. So delta E is equal to the wavelength of the photon. 0.0118 electron volts, or put it in joules actually, which will make solving for the wavelength a little easier. 2 times 9.43 times 10 to the minus 22 joules, which is equal to 2 times 9.43 times 10 to the minus 22 joules is equal to 1.87 times 10 to the minus 21 joules. All right, so now we can use the relationship that the wavelength of a photon, or the energy of a photon being emitted due to a transition, is just equal to that change in energy. So E is equal to hc over lambda, or since we want to solve for the wavelength of the photon, we just lambda is equal to hc over energy. I'll just, to keep nomenclature here, delta E, which is equal to 6.626 times 10 to the minus 34 joule seconds divided by, times the speed of light, which is c, which is 3.0, I'll just stick to keep with significant figures, 2.9, 2.99 times 10 to the 8th meters per second divided by your energy here, delta E, 1.87 times 10 to the minus 22 joules. So working through all of this, you get your lambda is equal to 1.06 times 10 to the minus 4 meters, or 106 micrometers. So now for part C, wants to know what is the energy difference for any delta N equals 1 transition. So for we want to know the change in energy between any change between delta N is equal to 1. So we're going to say N is n plus 1 minus E sub N, it's supposed to be an N, is equal to N plus 1 plus 1/2 h bar omega minus N plus 1/2 h bar omega. So now, simplifying this, we get delta E is equal to h bar omega times N plus 1 plus 1/2 minus N minus 1/2. These cancel, that just leaves behind a 1, which is just equal to h bar omega, which is equal to 2 E0, which in this instance is the 0.0118 electron volts, or the 1.87 times 10 to the minus 22 joules. And that's the answer.